This is the second double displacement or metathesis reaction where we're going to produce an insoluble compound. Now this reaction here has potassium phosphate and strontium nitrate. And what we're going to do again is change partners. So let's look at it. Down here we have potassium 1 plus combined with phosphate 3 minus. Now notice I'm not worrying about balancing the species. I did that when I did the original compound. So here I'm going to go strontium 2 plus and nitrate ion. Okay, we're going to change partners, so this cation is going to react with this anion and this cation is going to react with this anion. So we'll rewrite the initial species, and this is our molecular or condensed equation, and it's going to be K3PO4 aqueous plus SrNO3 2 aqueous yields. And here's where our products come in. We're going to switch partners. So I'm going to start with potassium and nitrate. Potassium is 1 plus, nitrate is 1 minus. Therefore, we need one of each to balance out. So I have potassium nitrate. Now, on the second species, we have strontium with phosphate. We have a 2 plus charge and a 3 minus. The smallest number that both of them will go into is 6. So that tells me I'm going to need 3 strontiums and 2 phosphates. And because the phosphates are a polyatomic, I'm going to put parentheses around them. So we've now got the compounds formed. Let's look into balancing them. On the right we have 3 potassiums. Here we're going to need 3 potassiums. We have 1 phosphate here. We have 2 phosphates here. Wait a minute, we're going to need a 2 in front here. Well, that just changed my potassium to not 3 but to 6. That's why when you work these problems you do them in pencil. So we have 6 potassium nitrates now. We have 1 strontium, 3 strontium, so we're going to need a 3 over here. That means we now have 6 nitrates. Oh wait, we have 6 nitrates. Life is good. Now we've balanced it. After we change partners, now we need to consult our solubility chart. Well, we have all nitrates are soluble, so that's going to imply that that one is aqueous. Let's go down and look at the phosphates. All phosphates are insoluble, which means they form solids except for sodium, potassium, and ammonium. Now, strontium is not one of those 3, so this means this is an aqueous species and this is a solid species. Now we move on to the complete ionic equation, which is where anything that can dissociate, which is aqueous, does so. Anything that's solid does not. So we're going to split it up into potassium ions. Now we have a 2 coefficient and a 3 subscript, so that gives us a total of 6 plus potassium ions. We distribute the 2 to the phosphate. We're going to distribute again. We have 3 strontiums, and because this is a complete ionic equation, we're going to keep the charges. This is 6 nitrate ions. And the trick also here is everything gets an aqueous or a solid. So we have a 6 here, potassium, plus 6 nitrates you are distributing. And then again, spaces is of premium, strontium 3, phosphate 2, solid. Okay? Because it's a solid, it doesn't break apart. Now, again, we've got our complete. Let's look and see what's the same. The nitrates are the same, and the potassiums are the same. We call these species spectator ions. Whoops, spectator ions. Because they don't take part in the reaction, they just kind of watch it. They're spectators. So once we remove those, let's see what we're left with. 2PO4, 3 minus aqueous, plus 3SR, 2 plus aqueous, yields strontium 3, PO4, 2, solid. This gives us a net balanced equation, which tells us what is actually going on in the reaction. This is the species that forms the insoluble salt or the solid.